All right, welcome back to our last section. In this section, we're going to talk about smart contracts and blockchain development. What are some things to keep in mind as you're developing a blockchain project? What are some of the differences between developing a blockchain solution and developing a more traditional solution? Um, and just what are some of the things you need to keep in mind along the way? Let's start off by talking about the difference between some terms: centralized, distributed, and decentralized. Now, as I mentioned in our first section, oftentimes in the blockchain world, you will hear these terms distributed and decentralized used rather interchangeably. But if we look at their exact definition, they do mean different things. So let's take a moment and just review what each of these architecture approaches looks like. And we're primarily defining each of these approaches in three different metrics. We're asking ourselves, number one, who owns and controls the solution itself? Number two, who owns and controls the data that goes into the solution? And finally, number three, who owns and controls the assets and infrastructure which deliver that solution? And it's important to keep in mind as we talk about all of these different approaches that none of these approaches are meant to replace the approach that came before them. We are simply adding additional tools into our toolbox. And each of these approaches should be viewed as a different and uniquely special tool. For example, it wouldn't make a lot of sense if you went out and bought a brand new set of wrenches and then came home and threw away all your screwdrivers. They're two completely different tools for different purposes. So let's start off talking about a centralized approach. In a centralized solution architecture, there's typically only one entity that controls all three components: the solution, the data that goes into that solution, and the assets and infrastructure which deliver this solution. When you think of a centralized solution, you can think of the way that many IT solutions were 15 to 20 years ago, where all solutions were maintained on-prem. So we had one single owner of the solution. That owner of the solution also owned and controlled all the data that went into it. And all the assets and infrastructure which delivered that solution were typically hosted in an on-site data center or server room. And that was a fairly limited approach. We only had one tool in our toolbox. And that worked great for some use cases, but it wasn't a perfect fit for all of them. So over time, we began to evolve into distributed solution architectures. And when you think of a distributed solution architecture, think of the cloud. In a distributed solution architecture, we still have one entity that maintains ownership and control of both the solution and the data that goes into the solution. But what we largely give up centralized ownership and control of are the assets and infrastructure which deliver and enable that solution. So Facebook is a great example of a distributed solution. Facebook owns and controls the solutions and the products that they build. And as we've heard so much about in the news over the past few years, Facebook also owns and controls all of the data that goes into those products and solutions. But what Facebook is largely given up ownership and control of is that third component: the assets and the infrastructure which deliver that solution. For that, they rely on cloud service providers like AWS or Microsoft Azure or DigitalOcean or others. And just like before, now we have centralized and distributed tools in our toolbox, and those work great for a lot of scenarios, but there's still some scenarios where either one of those two approaches is not ideal. And we talked about that a little bit in our last section about the incredibly quickly evolving business landscape and the need for intelligent CTOs to be able to provide technical infrastructures to their organizations in order to support radically new types of business relationships and scenarios. And so that has really driven us to now pursue decentralized architectures. And now we have a third tool in our toolbox. And in a decentralized architecture, we don't see centralized ownership or control over any one of these three components. There's no central owner of the solution. Rather, ownership of the solution is shared. There's no central ownership of the data that goes into that solution. Ownership of that data is shared. And there's no ownership of the assets or infrastructure which deliver that solution. That is typically shared or hosted externally. So think about the example we talked about with Ford and Volkswagen teaming up to work together to co-develop electronic vehicle technology. Who's going to own that solution? Who's going to own what they build? Well, it's not going to be owned exclusively by Ford or Volkswagen. Ownership is going to be shared between them. Who's going to own the data that goes into that solution? All the engineering reports and designs and specs. Well, again, that's not going to be exclusively owned or maintained or controlled by either organization. Ownership at that level is going to be shared as well. And finally, who's going to own that third piece? The assets and infrastructure which deliver the solution. Well, if Ford and Volkswagen are hosting their network nodes on-prem, then again, they would share ownership of that. If they choose to outsource that to host in the cloud with providers like Azure or AWS or Oracle or IBM or more, well, then they've given up centralized ownership and control of that third component as well. And Web 3.0 based solutions fall into this decentralized category. So again, in the blockchain world, you'll oftentimes hear these terms distributed and decentralized used interchangeably. But just keep in mind, if you're having a technical or very exact conversation, that there is a difference between these terms. Let's talk about another big difference between blockchain platforms, the pure blockchain platforms and the hybrid blockchain platforms. When we talk about a pure blockchain platform, we're talking about a platform where there is only one single place to store anything and everything. And that one place that we have, if we want to store something, is the permanent append-only immutable ledger, where the only things that we can do are create and read. A hybrid blockchain platform, on the other hand, is exactly what the name implies. A hybrid blockchain platform has two components. We have the permanent immutable append-only ledger, just like before, but we also have mutable storage, a traditional database or more conventional form of storage, where we have the ability to update and to delete as well. And this can have a significant ramification when you go to develop your blockchain application. And I'll come back and talk about that in just a second. But before we can talk about the ramifications of the type of platform you're building on, let's first understand what a blockchain application looks like. And in any blockchain application, you're going to have three primary architectural layers. And the technologies and components that go into each layer might be different depending on the blockchain platform or the other technologies that you're working with, how you plan to deliver this solution, who your target end users are, what other technologies your organization or organizations in your business network have made significant investments in, etc. But at a high level, you're always going to see these three layers. And we'll start at the top. At the very top, our first layer is the user interface layer. And when we talk about a user in the blockchain world, we could be talking about a line of business system or an automated system just as easily as a flesh and blood human being. But this user interface layer is how our end user, again, whether that's a human or another system, is going to interact with our solution. And in the cases where we're developing a user interface layer for a human being, you'll find that very often we're using exactly the same or very, very similar components to a traditional web application. So for example, if you are a user interface developer and you're used to building front ends in HTML and CSS, and now you want to build a user interface for a blockchain application, you can continue to use HTML and CSS completely unchanged, just like you were before. If you instead prefer to work with a framework like React or Angular or Vue, same thing. You can go ahead and build out that user interface using exactly the same technologies and tools and components that you're used to. So that's our user interface layer up top. At the very bottom, we have our smart contract or our smart contracts that run on the blockchain. And being that these run on the blockchain, this layer is always going to be decentralized. Now, here is where the type of platform that you select may really have some ramifications. If we develop a smart contract and we go to deploy it on a pure blockchain platform, where is that smart contract going to live? Where is it going to get stored? Well, anytime the question, where is something going to live or where is something going to get stored, gets asked about a pure blockchain platform, the answer is very simple. It is always that we are going to store that information or that data or that smart contract on the ledger, because the definition of a pure blockchain platform is one in which there is only one place to store and manage anything we might like to store or manage. So if we develop a smart contract on a pure blockchain platform and we go to release our code, we go to release our smart contract, that smart contract is going to live on the ledger alongside all of our other data. And like all the other data on the ledger, that means it's permanent. I'll come back and talk a little bit deeper about that, but just start to think about what some of the ramifications of that might be. If you're developing smart contracts on a hybrid platform, this is much less of a concern. And again, we'll take a little bit deeper look at that in just a minute. So we've got our user interface up top. We've got our smart contracts down below. We're going to need some kind of glue in the middle to join them up so that when a user does something in the user interface, that can send a transaction down to the blockchain. When that transaction or other information comes back up from the blockchain, we can go ahead and display it to our user. And we do that in the middle layer. And this middle layer is typically where we also build integrations or consume data from other systems if we need to. And again, just like the user interface layer, the components here are oftentimes the same or at least very, very similar to traditional web application development. So for example, if you have ever backed a user interface with some JavaScript code, you're going to find that many blockchain platforms take exactly the same paradigm. You're using JavaScript, Node.js in its native form, maybe with a few additional packages or libraries, but in most cases, you're not having to learn new languages or vastly new tool sets. All right, so those are our three layers. Now, our smart contract layer, because it's running on the blockchain, is always going to be decentralized. Blockchain is by definition a decentralized technology. But these upper two layers, the middle layer and our user interface layer, we can host these in several different ways. We can host these as centralized assets and resources. We can host these as distributed assets and resources, or we could host those as decentralized assets and resources. And I'll talk a little bit more about that, but first let's come back onto this idea about smart contracts being permanent and some of the concerns that you need to have or things that you need to keep in mind when you're developing on one of these pure blockchain platforms. Remember that the definition of a pure blockchain platform is one in which we only have one place to store anything and everything we want to store. And that is the permanent, immutable, append-only ledger, where the only two things that we can possibly do are create and read. So consider the following scenario. Let's say you develop version 1 of your smart contract and you release it onto one of these pure blockchain platforms, such as Ethereum. Little bit of time goes by and then you discover that there's a vulnerability in your smart contract. So as a responsible developer, you immediately go back to your code and you refactor your code to address that vulnerability, to close it so it can't be exploited and nobody can take advantage of that vulnerability. You then release the updated version of your smart contract. Well, in such a scenario, which you would have on a pure blockchain platform, is version 1 and version 2 of your contract, both on the blockchain, both live, both accepting and processing incoming transactions, albeit with different contract addresses. And that is because unlike traditional software development, unlike software development in the modern age, if you go and you update your code, you cannot update what is already in place. You cannot delete what is already in place and then replace it with your newer version. Remember, on a pure blockchain platform, there is no update. There is no delete. The only thing we can do on the ledger is create or read. And so this creates some really unique concerns that software developers have not had to deal with in well over 2 decades. Software developers used to have to consider things like this. In the pre-internet era, you had to make sure that your code, that your work really was tested and ready to go. Because if you discovered bugs or vulnerabilities or flaws after release, your only real choice was to mail out a set of floppy disks to every single one of your customers all across planet Earth. Well, the advent of the internet has made software development much, much easier in this regard. And as software developers, we've become very, very accustomed to the ability to update or delete our code in place. Developing on a pure blockchain platform takes us back in time in many ways to this era when it was not so easy to update and delete source code. You definitely have some planning to do at the beginning of your project if you're going to develop on one of these pure platforms. And if you follow software development methodologies at all, you might infer from this that an agile development methodology isn't really going to make sense, at least not post-release, if you're developing on one of these platforms. You really do need to go back into more of a traditional waterfall mentality. You only really have 2 choices, and either way you go, you need to do a lot of planning ahead of time, because either way you go, you do not have an easy choice in front of you. The first way that you can manage this scenario is to figure out, okay, how am I going to manage these multiple versions of my smart contract all live on the blockchain, living side by side? The second option you have is that many of these platforms offer what is called an optional self-destruct function. And this is something you must implement at design time when you're writing your code. But this is a function you can optionally implement. And if your smart contract has implemented it and this function gets called and it's allowed to run to completion, well, then your smart contract isn't going to go anywhere because it's permanent. It lives on the ledger and nothing on the ledger ever goes away. But your smart contract will go to sleep permanently, and it will never respond to another incoming request ever again. This can help alleviate some of the problems you might face having multiple live versions of a contract all on chain. But if you choose to implement this self-destruct function, you need to make sure you protect it, because the last thing you want is for someone else to inadvertently come along, either accidentally or maliciously, and call this function and shut down your smart contract. And this has actually happened before on the blockchain with disastrous and expensive consequences. And you'll find, if you get into blockchain development, that there are a lot of gotchas like this. There are a lot of things that on a traditional project we wouldn't think about or wouldn't consider, but they become big points of discussion and design and decision and alignment on a blockchain project. Another concern or potential concern if you're developing on one of these pure blockchain platforms, and that is smart contracts on most of these platforms, including Ethereum, are usually fully transparent. And this is very, very strange if you've done any software development in the past, because as software developers, we are not used to, unless it's an open source project, we are just not used to sharing our raw source code with the entire world. Typically, what we do as developers on a closed source project is we keep that source code internal and very protected, and we only share it with other team members and developers and architects on the project. What we share with the world at large is the finished product, the compiled binary. Well, you'll find that on many platforms like Ethereum, you can go in and find a smart contract and view the raw source code of that smart contract, not the decompiled binary, but the actual raw source code, comments and all. And this is very, very atypical. This is something we usually do not do in the software development world. But the blockchain world, especially the consumer side, takes a little bit different view. And that is, on the consumer side of blockchain, I can write an application and smart contracts that can work with your money. And those smart contracts might be working with large sums of your money. And the overarching philosophy is, if I, as a developer, am going to write a smart contract that has the ability to work with large sums of your money, you, as a consumer or user of that contract, should have the right to come view my work, to come vet my source code, to independently confirm that my smart contract does all the things I promised that it does, and that it does those things in a way that is safe and secure and acceptable to your personal standards. So again, this is very, very different, and this can be an easy trap to fall into. If our raw source code is going to have this kind of visibility, we want to be very, very selective about what business logic we put into our smart contracts. If I have some business logic that I want to keep secret, that I don't want my competitors or other participants in the marketplace to see, well, then I might want to consider putting that logic somewhere else. Instead of keeping it in the smart contract layer, I might want to put it in this middle layer in my application instead. You really need to think ahead about what you store on the ledger. And this is going to be true whether you're working with a pure platform or a hybrid platform, because they both have a permanent ledger. They both keep a permanent record of all the transactions and all the data that go through the system. So you really need to think ahead about what you're storing. And it's not just enough to think about, okay, is the data that I'm storing acceptable today? Because all of this is permanent. You need to really try and think ahead and future-proof your solution and ask yourself, is this data that I'm storing today going to be acceptable tomorrow or next month or next year or next decade or even next century? Because it's permanent. It's written in stone. It's not going anywhere. And of course, every use case is going to be different, but in general, that means that you should shy away from storing any kind of personal data, personally identifiable information on chain. And of course, if you're working in a use case that is subject to regulation, to oversight, to audit. A lot of the guidelines might already be there for you in terms of how you manage your data, what data needs to be destroyed, what data needs to be retained permanently, etc. You can use blockchain as a way to validate personal data or other data that is not appropriate to live on chain directly by using hashes or digital thumbprints. You remember we talked about this early on in our conversation about blockchain. A hash is this digital thumbprint that can only ever be generated by one specific piece of input data. Well, if I can't store your personal data on chain, your name, your address, your phone number, because that data might have to be deleted for compliancy reasons, for legal reasons. Well, one thing I can look at doing is storing your personal data in a database where I can delete it, where I can make it go away. But if I want to convince someone that that data in my database has not been changed or altered in any way since it was put there, well, I could store the digital thumbprint, the hash of that data on the blockchain, carved in stone, where it's permanent. Another thing to consider is the issue of data sovereignty. Does it matter where your data physically lives? And again, this is more an issue if you're pursuing a use case that is subject to regulation, oversight, scrutiny, audit, etc. And in a lot of use cases, where your data physically resides can be significant. Here's an example. In the United States, there is a series of federal regulations known as the Criminal Justice Services Information Act, or CJIS. And part of what CJIS regulations specify is that if you are working with any piece of data out of the U.S. criminal justice system, no matter how small or innocuous, if you are working with any piece of data out of the U.S. criminal justice system, you have to be able to prove to federal regulators anytime they ask at a moment's notice that all of the data you manage physically resides on servers within the borders of the United States. So if you're pursuing one of those use cases where data sovereignty is an issue, what happens if I take that data and I store it on a permanent ledger on a network that is made up of over 20,000 nodes all around the world? Well, I'm now in violation of that regulation, and I have no way to go back and put myself into compliance because the data that I've stored all around the world is now permanent. So data sovereignty, another big thing to think of ahead of time before you actually start writing that first line of code. I want to spend just a moment talking about decentralized content storage and one technology in particular, IPFS, or the Interplanetary File System. Now, this technology, IPFS and decentralized content storage in general, is not blockchain, but this is another Web 3.0 decentralized technology. And even though IPFS is not blockchain, it is used quite frequently in blockchain solution architectures for managing large volumes of data, documents, images, as well as sometimes for hosting solution components. So let's talk about what IPFS is. IPFS is the brainchild of a brilliant young man by the name of Juan Benet. And several years back, Juan was a freshman undergraduate at Stanford University, and he was sitting in Astrophysics 101, one of his undergraduate requirement classes. And one day the professor was talking about Elon Musk and SpaceX and their push to establish a permanent human colony on Mars sometime in the next 25 to 50 years. And at one point during the lecture, the professor was talking about the physical distance between Earth and Mars and how, at their closest points in their respective orbits, the closest Earth and Mars ever get is a 12 light minute delay each way. And then it gets even worse. There are 2 years out of the 2 weeks, out of the Martian year, where Earth and Mars can't even communicate with one another because they're on opposite sides of the sun. So Juan got to thinking about the internet. And how is the internet going to work when human beings become a multi-planetary society? And he realized that if, under the best case scenario, every web request you made came with a 24-minute delay, that was going to be unacceptable. 12 minutes to go to Earth with the request and 12 minutes to come back with the data. And one realized that problem was because the internet was centralized. And one of the big drivers of centralization on the internet is the fact that we use location-based addressing. So if you think about a URL, if I tell you to go to www.google.com, well, if you type that into your browser and you hit enter, that URL, that web address gets translated into an IP address by a technology called DNS. And every IP address points to a physical location somewhere on planet Earth where there is a server that has the information you're looking for. Well, it turns out addressing content by location is a really, really stupid way to address content. For example, imagine if I was giving you a book recommendation. I told you about this great book and suggested you should read it. And you thought it sounded like a good suggestion. So you asked me, well, what's the book? I want to go read it. And what if I answered that question by giving you a location where you could find the content? For example, what if I said, okay, if you want to read this book, here's what you have to do. Go to the New York Public Library, go up to the second floor, find the third shelf in from the right, and it's going to be the fourth book in from the left. So you book your plane ticket, you travel to New York, you check into your hotel, you get up the next morning, you take a cab down to the New York Public Library, you walk up to the second floor, you find the third shelf in from the right, you go to look for the fourth book in from the left, and wouldn't you know it, it's checked out. So you travel back home, wait a couple weeks, make a new set of travel reservations, head back, go to the library, and hope you can find the book then. You can see this is a pretty inefficient and ridiculous way to address content. If I want to share that book with you, I don't tell you where to find it. Rather, I tell you what to look for. I tell you, here's the name, here's the title, here's the ISBN number, and I leave it up to you to find it, whether you get that book from your local library, whether you borrow it from a friend or relative, whether you buy it from a local bookstore or an online retailer. I really don't care, and I shouldn't have to. All I'm telling you is the content to go find. Well, IPFS takes this model into consideration, and every URL or address in IPFS points not to a specific location, but to a specific piece of content. And this decentralized internet has the promise to really speed things up, to make the internet workable when human beings are separated by great distances. One of the other great pieces of using content-based addressing, every URL in IPFS is a hash, or the digital thumbprint of the piece of content being stored. So if I store version 1 of a document, and then I go and I make some changes and I upload version 2, well, both versions are going to have a completely unique address because they contain different content. So some very, very exciting things you can do with IPFS. And this becomes very, very exciting when we look at how we host our application. This opens up some incredible new doors to us. We talked about the 3 layers of an application: your user interface layer, your middle layer, and your smart contract layer. And we know that our smart contract layer running on the blockchain is always going to be decentralized. But our user interface and our middle layer, we have some choices on how we can host those. Because again, these layers are typically the same or very, very similar to what the corresponding layers would be in a traditional web application. So for example, if I have a blockchain application and I've built a front end using HTML and CSS, well, I can host those HTML and CSS assets just like I would a traditional web application. I can host them out of my on-prem data center. I can host them out in the cloud with a cloud provider. Or now with something like IPFS, I can host those layers in a decentralized format as well. And if I choose to go that route, I can have an application which is truly decentralized at all three layers. I have a decentralized smart contract layer, I have a decentralized middle layer, and I have a decentralized user interface. And this can be used to create extremely resilient solution architectures. By hosting all three layers in a decentralized format, you have essentially created a solution which is impervious to any kind of denial of service attack, any kind of censorship attack, and is going to be remarkably resilient if you're trying to use this solution in areas with unstable, unpredictable, or generally poor infrastructure. If the power is constantly going on and off, if you're losing and then regaining network connectivity, you'll find that these decentralized architectures are much, much more resilient. Of course, all of that comes at the expense of efficiency. So platforms like IPFS, in addition to just storing and managing the content that we want our application to work with, can also be a great option for hosting application components as well. On the enterprise side, you have some other concerns if you're going to dive into the blockchain waters. In general, there are two ways that a blockchain project or initiative starts over on the enterprise side. The first is what I call the consortium approach, and the second is the build it and they will come approach. And no matter which approach you take, you're still going to get to the finish line in about the same amount of time. It's just a question of, would I rather go fast at the beginning and slow at the end, or would I rather go slow at the beginning and fast at the end? So let's talk about the consortium approach. The consortium approach is one where you're going slow at the beginning, but fast at the end. And what the consortium approach says is, hey, let's go and let's form a consortium. Let's get all the participants in our business network together and sitting around at the same table before we start architecting and designing our solution. And you might ask yourself, well, what if there are no other participants? What if there's no consortium to form? And if that's the case, you may want to go back and double check whether blockchain is a really good fit. Because if you're only building a solution for your one organization, if it's never going to leave the organizational boundaries or extend beyond the castle walls, then likely you're going to be able to do everything you want to do using more conventional centralized technology. You'll be able to do it a lot faster, a lot cheaper, and a lot simpler if you go that route. But if we've decided, for reasons discussed in our use cases section, that taking that centralized approach isn't going to work, and we've seen that the reason that centralized approach isn't going to work has very little to do with technology reasons and much more to do with human and political reasons, well, then we might want to look at the consortium approach and say, let's get all of these stakeholders, all of these other organizations, and all of the important voices all sitting down at the same table right from the beginning, and let's make all our decisions together as a group. Now, there's some benefits and some drawbacks to taking this approach. The benefits are you're gathering all that stakeholder input right at the beginning, and you're getting alignment on every decision right from the beginning. And so that means when it's time to actually start construction, you're going to be starting at a much closer point to what your actual finished solution is going to look like. In other words, you're going to require fewer development cycles to get from the beginning to something that's production ready. Of course, the big drawback to the consortium approach is building this consortium and collecting everybody's input. This takes a lot of time. So the front half of this initiative is very, very slow, and we make it all up on the back end by being able to develop quickly. The flip side to this is the build it and they will come approach. And this is where we say, all right, rather than forming that consortium up front and getting everybody to the table, let's just go off in a vacuum. And let's imagine what the perfect solution might look like, and let's build a prototype of that. And then when we go around to show this solution to the other participants in our business network, to the other organizational stakeholders, we're not just talking about an idea, but we actually have something we can show as well. We can do a little show and tell. So again, just like before, there's some benefits and some drawbacks to this approach. The benefits are that you're going faster during that initial part of the project. You have fewer cooks in the kitchen. You have fewer viewpoints to consider. So you can nail down your prototype requirements and start development a lot easier. The other big benefit to taking this approach is that later on, when you do go to build that consortium and get buy-in and acceptance for your solution, again, you're not just talking about something nebulous, you actually have a working demo that you can point to help sell your vision. Of course, the big drawback here is that you're going slow during the back half of the initiative. When development actually starts, you're going to be getting a lot of feedback from those other stakeholders. Hey, your prototype was great to communicate the initial vision, but it's pretty far off the mark for what we're going to need for something production ready. Then you're going to have to go and collect all that other stakeholder input and revise your design. And this generally results in many more development cycles to get from start to finish. Again, both of these approaches, in the end, take about the same amount of time. It's just a question of which is more appropriate for your organization, your business network, the use case, your industry, your vertical, etc. All right. Question that comes up a lot is, hey, I've been learning about blockchain and I'm really excited about it. I think all of this stuff is going to have a huge impact on the world. But I'm not technical. I'm not a developer. I don't write any code and I don't have any desire to become technical. I really like my non-technical role in the organization. So can I do anything with blockchain or do I just need to be an advocate and a fan who kind of looks in from the outside? And the answer to that is yes, the architects and developers and technical resources are obviously important resources on a blockchain project, but I would go as far to argue that the non-technical resources are even more important. Because there's some pretty significant concerns that have to be addressed before we can even start writing our first line of code. And all of these concerns are radically different in the world of blockchain development initiatives, of decentralized development initiatives, where we're not just building a solution within one organization, but we're building something that's going to be shared and consumed and collectively maintained between organizations. And all of this is an extremely new discipline. We really haven't had to do that much of this at any large scale in the market before. So a lot of the best practices and guidance and recommendations and books and how-to guides and cheat sheets that we might be used to for other project management related concerns just aren't there yet. So Here's just a quick list. We could certainly expand this and go for many, many slides talking about all the concerns that open up when we look at doing a complex technical development initiative between organizations. But just as kind of a quick pass to give you an idea of some of the things we have to think about. Budgeting. If we're going to have multiple organizations all working together to co-develop a solution, who's going to pay for it? How are each of those stakeholders going to pay for their component? Is this a solution where we expect to realize significant cost savings, or a solution which we expect to generate revenue? And if so, how are those savings or that revenue going to be distributed amongst the participating organizations? Change management. How are we going to manage change requests along the way? Who gets to request a change? What kind of change can they request? When can these changes be requested? Are there certain time windows? Is there a change approval process, and what does that look like? When we introduce new changes into our project plan, how are those prioritized and scheduled? What other features are we bumping down the list to make room for these changes? And how are these changes paid for? All back to the same budgeting questions. All of this spills over into very, very non-technical areas as well, like customer acquisition. Hey, does what we're doing together change how we're going to go acquire customers? Think about Mercedes-Benz. We talked about how their adoption of blockchain might ultimately lead them to a place where they're able to work with their lenders by gathering information across their dealership and service center network to offer customers a lower rate. Well, that really changes customer acquisition. How do you go out and acquire customers? What's your messaging? What's your value proposition? What is your competitive relationship with other participants in the landscape? Human resources, a very typically non-technical area of focus. Well, if your organization and my organization are going to team up to go build a great blockchain solution together, what happens if we both need to go hire developers or architects or project managers? How do we coordinate that so we're not competing for resources and trying to bid each other out of the game in a price war? If we're both going to have to onboard new resources to go attack this new skill set, to do this new type of project, are there ways that we can work together on skills development and training and education and onboarding, realize some synergies and some cost savings there? How about information security? What data are we going to have on chain? Is that going to be acceptable on the future? Do we have a different view of information security? Is there a piece of information in this solution which I don't think has to be maintained very securely, but you do, or vice versa? Do we have different retention policies? Do you have a policy which says this piece of information has to be destroyed after 3 years, but I've got a retention policy which says it has to be kept on file for 7 years? How are we going to reconcile that difference? How are we going to support and manage this thing once it goes live? How are issues going to be reported, tracked, escalated, resolved, followed up on, etc.? How are we going to manage the overall project and program? How do we ensure that we're staying on schedule, on budget, that we're delivering to a stakeholder audience with properly maintained expectations? From the program or product management point of view, how does this individual solution align with a larger overall product offering? How do we report and share project status and metrics across organizations? Do different member organizations want different pieces of information reported? If so, what are those things that we need to report on? How does that need to be communicated? What's the frequency that we need to report on that data with? How about marketing and branding and promotion? Again, if our two organizations are working together to co-develop a solution, how do we promote it? How do we go out and sell it? If we're Ford and Volkswagen and we just developed this amazing new electronic vehicle technology, How do we brand that? How do we promote it? How do we sell it to consumers? Do we sell it as a joint effort? Do we sell it as just individual components in our respective technology portfolios? Do we need to have promotions and campaigns and messaging which aligns? What do we do if we just have vastly different corporate or brand cultures? How do we reconcile those differences? Do those differences matter? Are we going to be competing for the same customers? If we are, is that okay, or is that a problem? How about just the logistics of all this? Resourcing and scheduling. Where are your developers at? Where is mine at? Where's your team at? Where's mine at? How many hours in the day are we separated by? What are the hours we can communicate? When should we set up our daily stand-up call? What kind of things should we be talking about, etc.? And again, all of this is stuff that needs to be addressed, and we need to have a plan in place before the very first line of code can be written. And you'll see that these are all largely non-technical concerns, non-developer architect related concerns. So back to that original question. If you're this non-technical resource looking in at all this saying, hey, blockchain looks pretty interesting, but I don't feel like there's a place for me because I don't know how to actually write the code, you couldn't be more wrong. There's a lot of opportunity for anyone, regardless of skill set or background, to really make some significant contributions. Because again, all of this, doing this in a multi-organizational capacity is very, very, very new. All right, another big thing to consider, if we're going to have multiple organizations working together to develop a solution or a group of solutions, is security. Remember that old adage that a chain is only as strong as its weakest link? Well, if our two organizations are going to work together and your security is top notch, but mine isn't, well, guess what level of security we inherit? An IT solution will always, always, always inherit its lowest level of security. Think about your house or your apartment. Imagine if you go to bed at night and you lock the front door, and then you do a deadbolt, and then you have a couple chains on the door, and then just to be safe, you take a chair and you prop it up under the doorknob. And then you go to bed, and you're laying in bed feeling nice and safe and secure, but you left your back door wide open and unlocked. How safe is your house really? How secure are you really? A system always inherits its lowest level of security. And this means if you and I are going to work together, we need a good way to vet and review and rate and scorecard and analyze each other's security standards and practices. Security is a very, very subjective term, and what secure means to one organization or one industry or one culture or even one office or project team can be vastly different than what that same word means to another group. So it's very, very important to get on the same page about this before we start writing any code. All right. Well, once you've got an idea what you want to build, what are some of the things you want to start talking about and documenting? So in this section, what I've done is I've got a standard project design document template that I use anytime we go out and do any architecture or design work around blockchain or decentralized projects. And what I've done is just taken the table of contents and pasted it onto these next few slides, along with just some questions that you might want to ask yourself in each section. So let's talk about what some of the things you might want to consider are. And let me just preface this by saying there is no accepted format for a blockchain solution design document. So please view everything that I'm saying as just informative. And if you want to go write your own documentation that takes none of this into consideration, that takes all of this into consideration and extends upon it, takes some of it into consideration and discards other pieces, feel free. Again, there is no right or wrong way. I mean this only as guidance to get started with if you don't know where to start. So typically we begin this type of documentation with the executive overview, a short form. What are we doing and why? Meant for that busy executive who only has 60 to 90 seconds, only wants to read a couple pages. It is the TLDR version of what it is we're doing and why does it matter. The problem statement is where we go a lot deeper into, okay, what is the problem we're trying to address? And we want to answer two big questions in the problem statement. What and so what? What is the problem we're trying to address? What is it we're trying to achieve? And then, so what? Why does it matter? If we solve that problem, so what? Why is this important? Why is this a pain point? Or why is this an opportunity we need to capitalize on? Up until this point, fairly standard. Then we start to deviate a little bit from the standard. I like to right up front introduce the goals and definitions of success. And I like to do this by using the SMART goal framework. If you're not familiar with that, you can go Google that, read a lot about it. But this is a framework you can use to define your goals in objective, measurable terms rather than subjective terms, rather than the world of feelings. And the idea here is if we go out and we build the solution that's talked about in this document and we get done and we're having a retrospective 12 months later, 24 months later, 60 months later, whatever, pick your time frame. How are we going to know if what we did was successful or not? How are we going to know if we succeeded or not? And again, we want this to be very objective, right? We want to be able to go into that retrospective meeting and then walk out with everybody in 100% agreement. Yes, we were successful, or no, we were not. And oftentimes we don't have this conversation up front. So when we do that retrospective and we ask ourselves as a group, were we successful? We're not on the same page because we're using a subjective definition of success. Everybody views that term a little bit differently, and it means something differently to everybody. So making this part of our initial project documentation is a great way to build alignment on what we think that success is. And the M component in a SMART goal stands for measurable. Keep that in mind because we'll come back to that in a minute. Whatever goal we define, however we define success, needs to be something that we can measure. It needs to be quantifiable. All right, next up, guiding principles. What are the high-level design trade-offs? In any solution architecture, there are always trade-offs. We talked about a little bit earlier in blockchain, this idea of inefficiency. One of the things we talk about in a blockchain solution is, hey, how much performance and speed are we willing to give up for redundancy, fault tolerance, failover, immutability, etc.? Other guiding principle questions we might consider, how are we providing value to the end user? Are we doing it by creating a very simple feature-light environment, or are we doing it by creating a very powerful but complex feature-laden environment? How are we going to support our project after it goes live? Are we going to take a centralized support model? Are we going to adopt a decentralized support model where users are expected to go to the community around them rather than to whoever created or developed the solution? And these guiding principle decisions are important because we use these as a North Star, as a way to keep our project on track as we go further and further into our detailed solution design. Next up, we talk about our design and architecture, starting with our platform selection. So what blockchain platform or platforms have we selected to build on? Important to note that this could be plural. We are never, or oftentimes we are not, selecting just one blockchain platform. Very often, our architectures dictate the use of multiple blockchain platforms because I want to get features and benefits of each. Or oftentimes we are leveraging decentralized blockchain technology in concert with more centralized traditional approaches. So what platform or platforms have we selected? Why have we selected those platforms? What other platforms did we consider and reject? Why did we reject those platforms? We really want to prove here on the technology side that we've done our due diligence. We've done our homework. We looked at all the available options and tools, and this is what we deem to be the best, and here's why we have reached that conclusion. Then we'll talk about network considerations. How is all this going to be hosted and managed? This becomes much more complex when we have multiple organizations working together collaboratively to co-develop a solution. What happens if I'm going to host half of my servers on-prem and I'll keep the other half out in AWS? You're going to keep a few servers on-prem, but most of them you're going to split between AWS and Microsoft Azure. And then we have a third participant who's decided to host all their nodes with Oracle. How are we going to get all these different networks talking to each other? What configurations do we have to make? What security concerns are there? How do we have to configure our firewalls, etc.? Then we can talk about the solution components themselves. So what are the assets? What are the things we care about? And we've spent quite a bit of time already talking about assets in the blockchain world. What are the things that we care about and want to keep track of? Well, assets are great, but by themselves, assets are static. They don't do anything. Think about a stage and the set. You have all these props on the set, and they are critical to help tell the story, but they don't do anything in and of themselves. It's the actors and actresses that come on to the stage that really give it meaning, that bring life to it. So it's important we define the assets, the things we care about, but we also want to define our participants. Who are the actors on the stage? Who are the participants that are going to interact with those assets? When an asset and a participant interact with each other, well, that's what we call a transaction in the blockchain world. So what are all of these different interaction points, and what is the expected outcome of each interaction? Does one interaction need to cascade into another or kick off another, or is that the end of the sequence? So we'll define all three of those, the assets that we care about, the participants or the actors on the stage, and then all the transactions, all the interaction points between them. How do these assets and participants dance with each other? We'll define events. Remember, one way that you can look at blockchain is just as a workflow engine, a business process automation or process management solution. Well, if we take that view of blockchain and we say part of what we're going to be doing in our solution is automating or facilitating critical business processes that span organizational boundaries, well, then we'd want to ask ourselves, okay, are there any significant events that occur during this process or set of processes? Do I need to make any other participants, other systems, other organizations, other human beings aware of anything when these events occur? Think about systems integration plays. Do you want an event in one system to cascade something into another system? And finally, our queries. What questions do we know right up front we're going to want to be able to ask our solution and get an answer to? And a lot of this is much more defined than you might already think. Remember, early on, we defined our SMART goals. And I said that the M in the SMART acronym stood for measurable. Every goal that we define has to be measurable, has to be quantifiable. Well, that means we likely are going to need to define one or more queries to support that measurable goal. Here's an example. If one of our SMART goals said, hey, we want to increase customer satisfaction in the U.S. Northeast region over the next 6 months by 3% or more for the industrial product line. Well, if that's one of my goals, that tells me I'm going to need a query that can show me customer satisfaction by region, by time period, by product line. All right, are there any additional requirements, just kind of miscellaneous requirements that we want to document and call out? What's the general timeline of our events? We don't have to know the exact start and stop times, the duration, exactly how many hours every task is going to take. But we should, at this early point, at least have an idea of what the general sequence of steps is. For example, we are going to have on the timeline that we need to set up a development environment for our developers to work on well in advance of our first release. Because if we didn't do it that way, that wouldn't make a whole lot of sense. So we should at least be able to lay out the events that we know are coming in a proper sequence. And then we might be able to at least forecast some high-level durations or time estimates. What are the risks? Where could this all go wrong? Not just now, but in the future. What are the things that we need to consider, that we need to have on our radar, that we need to constantly be going back and evaluating as our solution ages and matures and grows? And then maybe the most critical component to any of this documentation is going to be your data dictionary. What are all the words that we use to talk about different things in this space? Why do we use those words? It's very, very important that we all try and adopt common terminology. And it's very, very common that if you get two different groups from one organization together, maybe you get IT and engineering or sales and accounting, you get two different groups within one organization together. And very oftentimes you'll find that they use different words or different terms to describe exactly the same thing. Imagine how much more complex that problem gets when we have stakeholders from multiple organizations all sitting down at the table. So if we're all going to start playing in the same sandbox, it's critically important that we're all using the same language to talk about the same things. So let's define what all of these items are. What do all our assets mean? Who are all our participants? What are all the things that we care about? And what words and terms do we use to refer to them? And then one final closing thought is that of future proofing. At first blush, this can seem maybe a little crazy or esoteric to think about, but it's a much more real concern than we oftentimes give it credit for. The solutions that you design and develop and the code bases that make them up can have a much, much longer lifespan than we originally envisioned. And we have seen this happen already. There are a couple great examples of this. For example, the IRS, the United States IRS, they are still using some of the same code that was written by IBM mainframe engineers in the early 1950s, almost 70 years ago. Now, obviously, that hardware, the mainframe systems themselves, have long been replaced, but this code has not. And that's not because it's perfect and it doesn't need to be addressed. And 70 years ago, developers wrote perfect code the first time. Far from it. It's that now that this code has been in production use for 70 years, there's nobody left in the workforce who understands that code, who could go make those changes. We would literally have to start over from scratch. And that would be a lot of work. It would be a lot of trial and error. It would be very error prone because, again, you don't have that expert on the existing system who can come in and tell you what are all the current features and functions and how do they all work and what concerns do you need to have about implementing any one of those. And it's not just the IRS who suffers from this. You can look at the Sabre reservation system that was developed in the 1960s, originally for American Airlines, but then adopted really all across the airline industry and in many other industries as well. Again, this is almost a 60-year-old code base that drives some of the most critical functions in airline reservations. Insurance companies are exactly the same way. Many of their most critical systems and code bases are decades old and cannot be adjusted or touched because all the expertise around that code base has simply left the market a long time ago. So it's not crazy to think about things like, hey, is the solution that we're designing and coding today still going to be used come turn of the century in 2080, 2090, in the year 2100? Again, it sounds kind of crazy to think about today, but I guarantee you, if you went back in time and asked that software engineer in the late 1950s, do you think your code is still going to be in use in the 2020s? I'm sure they would have laughed at you pretty hard. So as much as we can, we want to try and future-proof our solutions. And that's why thinking about things like IPFS and will my solution support a time when people are separated by vast physical distances, by light seconds and light minutes, not just miles or kilometers? Have I really thought through all of this? Have I really done everything I can to future-proof this solution as much? And I have a feeling that this is going to be very problematic in blockchain, because if you look at the areas like the IRS or with the Sabre reservation system, where these code bases have remained in use well beyond their originally estimated lifespans, they tend to be systems which automate and facilitate the most critical business processes that an organization has. Blockchain, as we've spent a lot of time talking about, is a technology designed to automate and facilitate critical business processes. And not just the processes within any one organization, but the processes between organizations. And so all the things that made all of these mainframe code bases from 50, 60, 70 years ago very sticky are just going to contribute even more in the world of blockchain solutions. So as crazy as it sounds today, at the beginning of this whole initiative, of this whole wave of Web 3.0 and decentralized technologies, as crazy as it sounds today to think 50 years, 60 years, 100 years ahead into the future, don't be afraid to, because there's a very, very good chance that your work is still going to be around in a long time. All right, and that gets us to the end. So if you've managed to stick with me throughout all this, let me first say thank you. This has been a fun topic to cover, but in a lot of ways it's been difficult because we've only just scratched the surface. And we could pick out any single one of these areas that we've talked about and likely spend a whole semester going in and doing a deep dive. Any one of these areas that you found interesting, if any one of them has been interesting to you, just know that you can go a lot deeper than what we've discussed. But if you've made it through all this material and you feel like you understand the high-level concepts and all of this has made more or less sense, then congratulations, you really are on strong footing to go become a blockchain expert. You don't have to go any wider in your knowledge base. From here, it's just going deeper on all the concepts that we've already introduced. But if these basic concepts make sense, then you are really well prepared for a world of blockchain and decentralized technologies. And if you find any of this exciting, I cannot overstate how incredibly new all of this is. This really is analogous to the internet in the late 1980s or early 1990s. We are just getting started with this. And one of the most frustrating and simultaneously exciting things about the world of blockchain and decentralized technology is that all the best practices, the recommended patterns, the anti-patterns to avoid, the do's and do nots, all of this is still yet to be defined. If you go out and you Google blockchain best practices, look at the number of results you get compared to database best practices. At least for me personally, every other technology that I've worked with throughout my career has already been in place by the time I got there. Those best practices, those recommendations, those reference architectures had already been decided and put in place by someone else, by other groups of people. And for decades, I'd always longed for a chance to be in the driver's seat, to get to take some of what I've learned and put that into future recommendations and best practices and solution architectures. And you might be the same way too. You might be the same kind of person who goes out and searches for something on Google, and when no search results come back, you get oddly excited because that means you found a green field and an area where you can make your own unique and significant contributions. And if that type of thing does sound exciting to you, then I really encourage you to go deeper into the world of blockchain and decentralized technology. Whether you're technical or non-technical, there's a lot of room and a lot of opportunity for you, and you can make some very significant contributions, and we need all the help we can get right now. If this is something that doesn't interest you, hopefully you see the potential in blockchain and you at least recognize that the world may look very different in the coming years and decades, all because of this new way of looking through the world and evaluating the most critical problems and issues that we have in front of us. So again, thank you for all your time, and I look forward to discussing this with all of you in greater detail when we have some of our live sessions.